Hey there, teachers. Welcome to this explainer for Combined Unit 4 and 5. Grab your coffee, maybe take a deep breath, because I'm here to walk you through exactly what you need to feel totally confident and ready to teach this unit. As a quick note right off the bat, we'll be talking a lot about our state TEKS today.
Look, we know setting up physics units can be, well, a lot, especially if science isn't your primary background. Between gathering all the physical materials and trying to make really abstract concepts concrete for the kids, it can honestly feel like a heavy lift. So we've gone ahead and distilled your entire lesson plan into a quick, practical walkthrough. Here is our roadmap for today. 1. Unit TEKS and mastery. 2. The science itself. 3. Common misconceptions. 4. Investigations and modifications. And 5. Vocabulary and word wall. Okay, let's dive right into Section 1, Unit TEKS and Mastery. We are tackling 3 specific TEKS in this combined unit. TEKS 5.8 focuses on energy transformations within systems. Think of a flashlight changing chemical energy to electrical to light. Then, TEKS 5.8b is all about demonstrating how functional electrical circuits actually work. And finally, TEKS 5.8c covers how light travels in a straight line and how it can be reflected, refracted, or absorbed. So, what does mastery actually look like by the end of this? Well, it's not just rote vocabulary memorization. It is heavily hands-on. Your 5th graders need to be able to build working circuits from scratch, accurately map out energy pathways, and confidently predict what light is going to do when it hits different materials. They need to explain the why using real evidence they gather in class. Moving on to Section 2, Core Science Content. To save you some serious time, let's break down the core science practically, even if you don't have a strong physics background yourself. When teaching energy transformation, honestly, the easiest way is to frame it as a journey. Have your students physically trace the path. It starts as chemical energy stored inside a battery. When connected, it travels through the wires as electrical energy, and finally it arrives at the load, like a bulb or a buzzer, where it transforms into light, sound, or motion. Following that flow makes the invisible visible. Now, when you get to lenses, you absolutely want to use total physical response, or TPR. Have your kids physically make an hourglass shape with their hands to represent concave lenses, which spread light outward. Then, have them make a football shape for convex lenses, which bring light together to focus it. Getting their bodies involved anchors that vocabulary instantly. Then we have the classic showdown, reflection versus refraction. Reflection is simply light bouncing off a surface, just like a rubber ball bouncing off a wall. Refraction, on the other hand, is light bending as it passes through something clear, changing its speed and direction. You know, like how a pencil looks mysteriously broken when you drop it in a glass of water? Let's head into Section 3, Common Student Misconceptions. Anticipating roadblocks is basically half the battle, right? Thankfully, your curriculum includes Paige Keeley's science probes to surface these misconceptions early. Take the crossed wires probe on day 1. You'll see students often assume you just need one single wire connecting a battery to a bulb to light it up. You have to heavily reinforce that electricity demands a full, unbroken circular path. It has to flow out of the battery, through the load, and all the way back into the battery to work. Later in the unit, the flashlights and mirrors probe brings up another huge one, the idea that only shiny things, like mirrors or metals, reflect light. You'll need to guide them to understand a fundamental truth. If we can see an object at all, whether it's a red apple or a wooden desk, it is because it's reflecting light into our eyes. No reflection, no sight. All right, Section 4, Investigations and Modifications. Now for the fun, beautifully messy part of the classroom, the labs. You've got 4 major hands-on investigations here. First, students build minimalist circuits in 10 items or less. Then, they test mystery items like buzzers to see energy transform. Third, they become energy transformation detectives, literally dissecting flashlights to map the internal energy flow. And finally, they rotate through laser stations in Follow the Light. For your emergent bilingual students, these heavy vocabulary labs can be tough, so lean hard into those TPR hand motions we talked about. Point out Spanish cognates on your word wall, words like reflexión for reflection and energía for energy. And absolutely let them take initial data notes in their home language so they can just focus on grasping the science concepts first. Okay, quick but crucial safety note for the Follow the Light lab. You have to strictly monitor those laser pointers so they are never, ever aimed at eyes or faces. And hey, here's a fantastic teacher pro tip for you. If you spray a quick, tiny mist of hairspray in the air above the desk, it magically reveals the actual straight-line laser beam to your students. It's a total game changer. And finally, Section 5, Vocabulary and Word Wall. Let's lock in that academic language. You aren't just slapping pre-printed cards on a board. You're building an interactive word wall dynamically with your students, using real objects, realia. Tape an actual wire and switch up there. Pin up a square of black paper to anchor the word absorb and white paper for reflect. Making it tactile and interactive is what actually makes the vocabulary stick.
Your curriculum also gives you these exact, powerful sentence frames. They are essential for helping kids structure their scientific thinking. I'm going to read these verbatim right now with intentional pauses, exactly the way you should deliver them to your class so they can fill in the blanks. Ready? A complete circuit requires blank, blank, and blank. A light bulb transforms blank into blank. For a system to work correctly, the components blank. Lenses cause light to... By anchoring your lessons with these sentence frames and utilizing all those hands-on labs we've covered today, you are completely equipped to rock this unit. So I'll leave you with this. Which of these messy, brilliant, hands-on investigations are you most excited to set up first? Have a fantastic unit, teachers!